critical values of R for each situation. Now we're talking about linear correlation. The critical values, when you talk about linear correlation, are threshold values when you compare it against the R to determine whether there is a significant linear correlation or not. The R is the linear correlation coefficient based on the data. You compare that with the critical values to determine if there is a significant linear correlation or not. For this problem though, we only want to calculate the critical values. If we look at number 1 here, we have N. N is the number of pairs of data that you have. And then alpha is the significance level. That's the probability of rejecting that there's no linear correlation when there actually is no linear correlation. You can think of it as an error probability. So with number 1 here, we have N as 15 and the alpha as 0.05 or 5%. Now the way I'm going to do is I have a table. You need to be able to look up a table. This one's titled Critical Values of the Pearson Correlation Coefficient R. It has 3 columns. The first column is N, the number of pairs of data. The middle column is when the significance level alpha is 0.05. And the third column is when the significance level alpha is 0.01. So for this first problem, I'm going to go down to an N of 15, and then I go to the right to the middle column where the alpha is 0.05, and I get 0.514. An important thing you need to realize is that these critical values come in opposite pairs. So when you write out the critical values, you need to include a plus or minus sign. So the critical values for number 1 here is going to be plus or minus 0.514. Looking at number 2, we have 5 pairs of data with a significance level of 0.01. So on the table, I'm going to go down to 5, and then I go to the right to the third column, and I get 0.959. Again, don't forget to include the plus or minus sign. So we have 2 critical values for each situation. They come in opposite pairs. And then the last one, number 3, the number of pairs of data is 50. I'm going to go down to 50 on the list. And the alpha is 0.05. That's the middle column. I get 0.279. So this is going to be plus or minus 0.279. This is how you find critical values when you're dealing with linear correlation.